So in this video, I'm going to talk about the reactions of alkyl halides, but specifically substitution and specifically Sn2. And so it's important that whenever you see Sn2, you think of this as one step. So, and it's also called bimolecular. Bimolecular. So essentially what happens is you have an alkyl halide, and then you add a strong base. So NaOCH3. And so this, it's important to remember whenever you see Na, that's going to be positive. So essentially this is an ionic bond between a positive sodium and a negative OCH3. And so this is the base. Then the result you're going to get is OCH3 and then a Br minus. Br minus. So these are the products. And so as you can see, substitution, you're literally just substituting the OCH3 with the Br. So essentially that just switches places. That's pretty much what the substitution is. But it's important to know the mechanisms, which we're going to talk about in a second. And so, as you can see, this bromine right here is a primary bromine, which means it's bonded to a carbon that has two hydrogens on it. So hydrogen there, hydrogen there. And so what's going to happen is, let me just draw a better picture of this. So you have so this is what the molecules would look like. So you have a partial positive on this carbon right here. You have a partial positive. And so as a result, the mechanism of this is this OCH3 is going to attack that carbon because it's partially positive. And as a result, when it does that, it binds to that carbon, and this bromine has to leave because the carbon can't have 5 bonds. So the bromine leaves because it's the most stable leaving group. Like, it's the best group that can just leave on its own without binding again to something else. So it essentially, the nucleophile, which is the OCH3, pushes out the leaving group. And so this process happens simultaneously. And that means that it's concerted, because there are no intermediates and no carbocations. And so one really important thing to remember is that primary substrates always choose Sn2. And you're going to have to learn how to distinguish between whether something undergoes Sn1 or Sn2, and we'll talk about that more in the future. But it's important to know that primary substrates, such as this one, always choose this path. And that's because essentially the H's, the hydrogens here, are very small, and so as a result this group can have easy access to this carbon, and there's nothing like in the way, so to speak. And Another thing I have to mention is the transition state. So for Sn2 reactions, you have a transition state. So let's say you have a carbon there, hydrogen, hydrogen, the same thing we drew earlier. So now these dashed lines represent partially broken or bonds, right? Because carbon can have 5 bonds, as you'll see. And then HCO. And so as you can see, this is the transition state. It's really high energy. And on a reaction diagram, you would have the beginning, the reactant there. It would go up and down, and that's the product on the right side. And so you usually designate the transition state with that symbol. And so that symbol represents this whole structure. So you can find this whole structure located at that point in the reaction diagram. And so these, remember, are partially formed bonds. And this is a partially broken bond. And because this is only one step, to modify the rate at which this occurs, both the substrate and the nucleophile have to be changed. And we'll talk about SN1s where that differs a little bit, but it's important to remember to change the rate, substrate, and nucleophile matter. And in the next video, I'll discuss the factors affecting the SN2 reactions, but for this video, it's important for you to take out of this, the important things is that Sn2 reaction is one step. It attacks the nucleophile, which is the OCH3 minus. It attacks from the backside and essentially kicks out the bromine or the alkyl halide, whatever is there. And essentially, all that really, the overall picture is that the nucleophile replaces the alkyl halide. And so I hope you found this video helpful. If you did, please give it a like and share it with your friends.